Hi guys, myself Hardik, and in our previous class we have completed the IR sensor schematic, and now in this class we will complete the PCB part. So let's start. So before jumping to the PCB part, we have to assign the footprint first. So let's assign the footprint. So let's start with this LM393 IC. So to assign the footprint, we need to open the data sheet first. So let's open the data sheet. So yeah, so here is the data sheet. So here is our data sheet, and here is the available packages for this IC. So this is SOIC8, and these are the different packages. In this PCB, we are going to use DIP package because it is through hole component. The full form of DIP is dual inline package. So these are through hole components, so they are very easy to solder. So that's why we are using this P DIP package. The P stand for plastic. So this is plastic DIP package. So in every data sheet, if you go on the bottom side, you get some drawings. So let me show it to you. Yeah. So these are the drawings for different packages. Let me open it for dip. Yeah. So here we have all the drawings. So let's understand this first. So the width is 7.62 mm, and complete length is 8.26. So we will assign this footprint. So let's to assign the footprint, double click on it, and we have this option footprint. Click on this library icon. So here we need to write dip. So we will check on this pin count, and we have to use this 7.62 mm package. This is the longer one. We don't want this one. So this is the longer package. So this is not we want. Yeah. So this is the package we want, and this one is also having 7.62 mm, and here we have also 7.62 mm. So we are going to use this package. So let's click on OK, and here OK. So we have successfully assigned the footprint for LM393. So you can just double click on it, and you can also see here is our footprint. So if you want to see that package, so here is the package, and you can also see the 3D model of it by just clicking on this button. So yeah, so this is a 3D model of it. Let's click on OK. And so now let's assign the footprint for photodiode and IR LED. So let's assign the footprint for photodiode. So double click on it, and here we have footprint option. We will type LED. So we are not going to use SMD components. So we are using through hole components. So we are going to use 5 mm photo LED. So we have a black IR LED. Yeah. So here we go. So this is 3 mm. So we are not going to use 3 mm. We are going to use 5 mm one. So here is the 5 mm one. We will click on OK. Okay. So we have assigned the footprint for photodiode. Now similarly for IR LED, let's click on footprint, and let's assign the clear one, LED 5 mm clear one. So let's see the 3D model. So this is a 3D model of it. So let's click on OK. Done. So we have assigned the footprint for IR LED and photodiode. So let's assign the footprint for these resistors, these R1, R2, R3, R4, R5. So for that, we can use footprint assignment tool. So for that, we can go on tools, and there is a footprint assignment tool. We can click on that. So here we have all the components we have used in this schematic. So we have assigned the footprint for LM393, and we have assigned the footprint for this photodiode, and we have this IR LED footprint. Now we will select all the resistors and we can search footprint for them here. So let me type resistor, and we are going to use 9 mm through hole component, and in horizontal one. So let's use this footprint. So you can open this by clicking right and click on this view selected footprint. So here is our footprint. This is little longer one. Let's use the short one. Yeah, let's use this 12.7 mm pitch. Yeah, this is good to go. So let's close this and let's double click on it, and it will assign the footprint to them. So by using this tool, we can assign multiple footprints simultaneously. So let's assign the footprint for this indication LED. So we can search LED underscore PH. Here we are going to use 3 mm LED. This is not the one. Yeah, so we can use this footprint LED through hole 3 mm clear one. We can view this footprint. Yeah, this is good to go. Let's close this and let's assign this by double clicking on it. So now let's assign this header. Let's type header 2.54. So we don't want to use this IDC header. We want to use normal header. Pin header. Yeah, so here we go, horizontal one. View on it. So this is the footprint, and let's see the 3D model. Yeah, so this is good to go. Let's close this. Let's assign this by double clicking on it. And now we have capacitor. So let's search the footprint. So here we want to use through hole component, radial 4 mm, radial 4 mm. Let's use this 2 mm. Yeah, so we can see the footprint of it. Yeah, so we are good to go. Let's assign this. Double click on it to assign this footprint. So yeah, so we have assigned all the footprints. Let's click on OK. Now let's save this. To save this, you have two options. You can use Ctrl plus S shortcut key, or you can click on this icon. Now let's run the ERC. So we have this icon here. So if we click on it, so this is electrical rules checker icon. So let's click on this run ERC button. It is giving us these errors. Let's understand one by one. Input power pin is not driven by any output power pin. Okay, no issues. So let's fix this. And another one is symbol U1 has input pin, but unit A is not placed. Okay, so in our initial, when we are designing the schematic, so we have removed this unit A. So it is giving us error that you haven't used it yet. So let's fix both of them. So the first one is power error. So in KiCad, we have to tell from where our power signal is coming and where the ground is. So so we have to place a power flag. So we can find power flag in power port icon. So we can search here power flag. Yeah. So here we have power flag. Let's click on it. So let's place this here because here is our power entering, or let's place it here. Our power is entering from here, the header one. So let's place this here. Let's click on it and shift it here. And let's copy this 5-volt symbol. You can rotate this by clicking on R, and let's join them. So here is our power entering and power is exiting through ground. So let's copy this. Let's reduce the distance between them. Copy the power flag again. R to rotate. And let's connect them. Let's reduce little more distance. Yeah, we are good to go. Similarly for the plus 5-volt, let's arrange them. So this is telling KiCad from where our power signals are coming from. Power signal comes through this 5-volt and goes through this ground. And another error is we remove this unit A while making the schematic, so no issues. uh, what we can do is let's just copy it and paste it here and open its property section. Reference, we will change the reference of it U1 because this is the U1, and unit is A. Click on OK. And we don't want to connect this. So when we don't want to connect any components in KiCad, we have to place this no ERC symbol on it. So let's place this on these 3 terminals. Yeah, so let's save this and let's run ERC again. I hope there will be no errors now. Yeah, so now we have 0 errors. We have resolved all the errors, and now we can make PCB. So we can close this and go on KiCad, click on this PCB file. So it is blank, no issues. So we can import all the changes. So we have to go on tools first, and there we have an option update PCB from schematic. We have to click on it. So these are all the changes we just did, the footprint one and all those. So let's click on update PCB and click on this close. So here are our components. So let's place them by clicking on this. Now we can start making PCB, but before that, let's go on the board settings. So it is in this icon. Let's click on it. So in this board setup, we have all the settings for this board, for this particular PCB board. So here we have all the layers, like we have front fabrication layer, adhesive, paste, silk screen, and all those. So we are not changing anything here. And here are our constraints, which I already told you in our earlier classes. So here we have to write the constraints of our PCB manufacturer so that whenever we void that, it KiCad gave us error. So I'm going to import all these settings from my previous projects. I'm going to select all those. Uh, we can also click on this import settings. And now I have successfully imported all the settings. Click on OK. Now let's start placing components. For doing that, let's open the schematic side by side. Exit from the full screen. Click on. Let's close this property panel and shift on the left. Similarly for the PCB, shift on the right one. So this makes our life very easy. Whenever we select any components in the PCB, it automatically highlights in the schematic sheet. So let's suppose if I select this LM393 IC, it will automatically get highlighted in the sheet. So here we go. Let's arrange all these components. So let's start with LM393. So you can move these components by simply dragging them. Let's select this header. So this register is on output. Okay. So we are arranging components nearby. So let's arrange this output register near to the output pin. And so this is our output register, and here is our LED, and this is our output LED, and here is our register. So let's rotate this register. So we have arranged this register, and this LED. So let's arrange the rest of the components. So let's arrange this photo register and this IR LED. Let's rotate this. So there is a register associated with them. So let's arrange them too. So this is making cross. So we want to avoid making these type of crosses. So what we can do is we can just select this component and rotate it. So now there is no cross. So they are aligned properly and we can easily route them. So earlier it is something like this. It is making cross. So now we have rotated. So there is no cross and we can route them very easily. So this is the IR LED register, and here we have photodiode register. So let's arrange this also. Which resistor is this one? Let's select it. Okay. So we need to place it near these two resistors. So this is voltage divider. Okay. So these both are adjacent. So we can select both of them and just rotate it. And where is our capacitor? So here we go. Here we have our capacitor. So let's place it near our power input. So let's just rotate this by pressing R. Yeah. So now both terminals are nearby and there is no cross between them. Okay. Now we can switch this to full screen and let's shift all these components in the middle of the page. Now let's arrange these components. Okay. So let me connect my mouse so that I can easily navigate through this. Okay. Now I have connected my mouse. So now routing will be easy for me. Yeah. So let's clean this and arrange and optimize these components for the routing. Okay. So here we have ground. Okay. So this we need to connect with Q1C net, Q1C net. So let's select both of them and rotate it. So we can remove these names, so we don't need them. So let's remove them. So now it is little bit clear. Now we can arrange. Here we go. Okay, so there is our output. Let's put this inside the register. Similarly for all. So let's rotate this. Both beds are adjacent and close to each other. So we can also rotate this name. Similarly for capacitor. Let's rotate this designator. No, what if select both of them and rotate it? And Let's rotate the designator. Let's arrange these designators inside the register itself. And similarly for this LM393 IC. So here you can see all wires are crossing each other here. So we can resolve this by just putting the output on the first pin and 5 volts on the bottom pin. So let's do it on the schematic. So let's just select it and let me cut it. Let's paste it. So this is our current circuit. So what we can do here is just select it and click on R to rotate it. Select this and let's open the property for this. So here we have our properties. So let's mirror Y. Okay. So now first pin is output. So we change this pin. So now first pin is output and second pin is ground and third pin is 5 volts. So let's save this first. And now we have to import changes. For that we go on tools, click on update PCB from schematic, click on update PCB and close this. Now they are not crossing each other. We can easily route them. So we can also see the 3D view of this. So for that, we can go on view, click on 3D viewer. So this is the 3D view. Let's just close this. Now we will align all 3 registers. So for that, we have to select them first and right click on the mouse and go on align and distribute option. Click on align to left. So now they are aligned to the left. So similarly for these registers, so same we have to do with these registers too. Click on right and align to the left. You have to distribute vertical by centers. Distribute vertical by center. Now the distance between them is equal. This distance and this distance. So similarly for these registers too, select them and align them. Align vertically by centers. Yeah. So now they are aligned. Now we have arranged all the components. Now we can start routing. So before that, we have to set trace width. So we can set trace width in the board setup settings. So there we have design rules, and in design rules, we have predefined sizes. So as I import all the changes from my previous projects, so this is already filled. In your case, this you need to fill them manually. So to fill them manually, you just have to click on this plus icon and you can write your trace width. So right now, I'm going to use these 3 trace widths. So let's click on OK. After that, you have these 3 options for the trace width. So now let's use 0.3 mm and let's start connecting them. To start routing, you can click on X shortcut key on the keyboard. Similarly for this one, let's connect this LED. For power traces, we are going to use 0.5 mm. Click on X again. So this trace is little bit wider. And where is our power signal else? Yeah. So yeah. So let's connect them. So we can remove this. So we have to connect them to, click on X. So let's connect the signals. So for signal, we are going to use 0.3 mm. Let's make it again. Yeah. So we are good to go. Let's connect this output. We also have to connect this one. So don't worry about this 5 volt. We can connect them on the front layer. So yeah, we need to connect this net also. Let's shift this little bit. And what else? Okay, so we need to add this one also. So let's connect them. Press X. So all this is in back layer. So from here, we can change the layers. So right now, this icon is on red. That means we are on top layer. So now we can connect these 5 volts. So let's change the trace width. Now we have 5 mm width. Click on X to route them. Now only ground is left. Let's see in 3D. Now let's define the shape for this board. So for that, we have to go on edge cut layer. Just click on it and click on this square icon, and we can make a rectangle. So this defines the board outline. So let's shrink this little bit. Similarly from this side. And let's move this D1, Q1. Now let's connect all the grounds. For that, we have to go on front layer and click on this draw field zone icon and click it. Select both layers and connect this copper fill zone to ground and click on OK. Now make a bounding box around this PCB. So now if we click on B, it will reboot. And now all of our ground is connected to this filled zone. So this ground is connected on the bottom side, and similarly for the top. So all of our traces are now connected except this one. Let's connect these two. Click on X. Let's connect them on the bottom side. Change the width. Yeah. So let's repour it. Let's refill this. So to refill it, you can click on B. Yeah. So let's remove this J1 and let's see in 3D. So this track is on very edge. Let's shift this little bit inside. Click on B. So let's put a name on this PCB here. So to write something on this PCB, we have to go on front silk screen, click on it, and click on this T text icon. And let's write IR sensor module. Click on OK. Let's increase the size and make this bold. Width, what about 1.25 mm, and height is also 1.25 mm, and thickness is 0.3. Click on OK. So here we go. So this is a little bit bigger. So let's shift this and click on OK. So here we go. So now if we see on 3D, So we have write the name on it, IR sensor module, and also let's write the pin name here. So this output terminal pad is in square. So there is a convention. So the square one is ground. So let's change them. And the circle one is signal. So let's change this. So to change this, just select this pad and double click on it. So we have this pad properties. Change the pad shape rectangular to circular and click on OK. So similarly for the ground one, double click on it and change the shape in rectangular, click on OK. And for the 5 volts, just and similarly for the 5 volts, double click on it and we are going to use chamfered rectangle and chamfered corner. In the chamfered corner section, just select all. Yeah. So click on OK. So by just seeing these pad shapes, we can identify which pin is output, which pin is ground, and which pin is 5 volts. So let's write a small text also. Let's write out on back screen. Click on OK. Now we can see this by just viewing in 3D. Okay, so the text is mirrored. No issues. We can change it. So let's go on the back layer. Double click on it to open the text properties and click on this mirror. So let's increase the width 1.25 and similarly for the height and thickness. Let's use 0.12. Or what we can do is just remove this or go on the front layer, just copy this, go on the back layer, paste it here, modify the properties, rename the text output, change the layer in bottom full screen and mirrored it. Click on OK. So now we have similar format text. Just copy it and paste it again. Rename this ground and similarly copy it again for plus 5 volts. Click on OK. Let's just write 5 volts. Click on OK. So now we can arrange them a little bit. Now select all these and align them. Align to the left. Sorry, we have to align to the right. Align to the right. So yeah, we are good to go. Let's see this in 3D. So here we go. This is our 5 volts and this is our ground and this is our output. Okay, so it is clearly visible. Let's write version name on it. Let's just copy this and let's write it here. V 0.0.1. So we can see this in 3D. Yeah, so we have write the version name, our indications are there.
So our IR sensor module is completed, and if you have any doubt, please do let me know.